Okay. Suppose that functions f and g are differentiable on the open interval a to b with f of c equals g of c for some c between a and b. If f prime of x is less than or equal to g prime of x for all x between c and b, prove that f of x is less than or equal to g of x for all x between c and b. Is the converse true? Explain. All right, we will start a proof. All right, I'm going to define h of x, and I'm going to define it based off of this assumption. So I'm going to have h of x be f of x minus g of x. So h prime of x will be f prime of x minus g prime of x, which we know from this assumption, if we subtract that over, is less than or equal to 0. That's nice to have. And what I'm going to do is I'm going to consider the mean value theorem on h from c to some x value. I'm choosing c because we have this nice condition where fc minus g of c, if I move that over, is equal to 0. So that should cancel out nicely from the mean value theorem. So let's start doing that. Since h is differentiable, it's differentiable since f and g are differentiable, and it's just f minus g. So h is differentiable. Since h is differentiable and continuous, by the mean value theorem, there exists a c that's between, let's choose the interval carefully here. Let's say it's between c and x. Yeah, there's a c such that it's between c. I suppose I don't have to use c here. I could use another variable to make this less confusing. But it's not going to change anything structurally in the proof, I believe. So I will move on, such that h prime of c is equal to, mean value theorem says that we have f of x minus g of x minus f of c minus g of c, and we are dividing by x minus c, and we see that this becomes 0 by this condition, and so this is equal to f of x minus g of x over x minus c, and h prime of x, we know is equal to this, which we said earlier was less than or equal to 0 for all x. And so because h prime of c is equal to this, we can carry that over and say that's less than or equal to 0. So we can just look at the numerator. So f of x minus g of x is less than or equal to 0, which implies that f of x is less than or equal to g of x. Yes. Implies that f of x is less than or equal to gx for all x between c and b. That's the proof done. And the claim, is the converse true? No. The converse is not true if we consider f of x to be a piecewise function, x squared sine of 1 over x, if x is between 0 and 1 and 0, if x is between -1 and 0, and g of x to be x squared. Okay, first of all, yes, f of 0 is equal to g of 0. G of 0 is clearly 0. F of 0 is this 0 because we're hitting that 0. And so they're equal. So we have the first assumption. And further, we're assuming the converse. So we're assuming if this, then that. And f of x is less than or equal to g of x. So f of x is definitely less than or equal to g of x because sine is bounded above by at most 1. So all I could do is make it smaller, can't make it bigger. It's between -1 and 1, can only make it smaller. And if we consider the derivatives, we have f prime of x is equal to, I'll just write the derivative of the top half bit. Is this, and g prime more clearly is just 2x. And cos, the cos x oscillates between -1 and 1. And so you'd be subtracting a negative, would be adding. And so you would have examples that were greater than just 2x in this, to kind of loosely explain. That's that.